Bill Helm, critical case engineer here at Novarad. Bill has been with Novarad for 17 years and has worked in a variety of roles and teams within the technical support department. For 11 of those years, Bill was the data service team lead, where he specialized in building, integrating, and utilizing HL7 interfaces and engines to assist and improve facility workflows. Currently, he works as an escalation engineer, where he specializes in providing support for all aspects of HL7. Alrighty, I will now turn the time over to Bill.
Thank you very much, Erica. I'm going to share my screen, and it takes me just a half second to get there. So can everybody see a screen that says Introduction to HL7? If you can't see it, say something, and it might just take a minute or two to get through, or a second. I will take silence as being a positive note in this case. So what we're going to do today is we're going to talk about HL7. I mean, obviously that's why you're here, but we're going to just talk about some very basic aspects of HL7. We'll see why it was created. We'll look at a simple use case. We'll talk about how HL7 messages are communicated. We'll look at a simple HL7 message, how it's constructed, and get to look at how the data is being placed within it. And then we'll talk about what to do if in your situation with Novarad, if you're getting an error with HL7 message transmission. So hopefully you'll get a lot of information out of this. So why HL7? In the late 1980s, a group of physicians and developers got together and they discussed how horrible it was to try to communicate data reliably in a safe and rapid manner between each of the groups that are involved with hospital information. They found that if they wanted to create a software program where things seemed to be off or pretty seamless, they had to find developers that were familiar with the medical industry, and I got to tell you, that's not as easy as it sounds. They had to find, or settle on a database that would be used by all of the involved parties, and they had to agree on having some sort of a programming platform to go underneath it all. And it needed to usually be the same so that everybody was familiar with it that was doing programming. Worse, they had to, all of these individuals had to have access to each other's data and software. And it turned out to be kind of a lengthy process to get to try and share data between medical industries or medical vendors or whatever you want to, whatever I should state this as. When you had a hospital or two hospitals trying to communicate, it ended up being pretty difficult. They found that creating schedules for medical procedures that would link with multiple vendors was almost impossible. They found that exchanging consistent patient information and procedure data was nearly impossible because each vendor had different methods for storing its data. So, for example, Hospital A may save their patient IDs as A00123, and Hospital B might save their patient information as 12345, and the two just don't match up. One particular vendor might use middle names coupled with first names, and another vendor might put suffixes at the end of a last name. So, Dr. Jones would be Jones Doctor or Jones Doctor in their software or something to that nature. So there were a lot of things that had to be overcome in order to share data between between vendors. They also found that and they discussed that providing reports via print, fax, or email was not possible at that point in time. In the late 80s, email was almost a reality. I mean, I worked in the industry. I realized that we had some great email platforms at the time. America Online being, the top-notch provider at that point, but there was really no way to provide um, secure data transmission with all this information and any one of those types of communication medium. And then all of the above, everything that we've talked about just required some wildly complex software diagramming and programming, and it would take months and months to complete. Um, the the doctors that were part of this team that created HL7 were notably, vested in the possibility of making something a little bit easier. Once in the situation we just talked about, once a project would be completed, by the time it was done, technology had moved on, and they'd need to have a brand new program created. So they'd have to get all these developers and all these people back together, and it, it was an ongoing process, and it seemed like a never-ending sinkhole, a place to throw money. Um, Worse, new laws like HIPAA would require that there's changes to their software. Facility might add a new software vendor who didn't agree with everything that they'd already done, and the list of difficulties goes on and on. Um, a completed project or once a project was completed, the software program that was made couldn't be used with different vendors. It would require usually a specific programming language, and if company decided to bring on a new hospital or a new medical vendor of some sort, you know, they would have to start this whole process over and hope that everybody could get together. So I mean, I know that sounds like a lot of information as to why HL7 was created, um, but that just kind of scratches the surface because there were bugs that would come up in the software, and bugs wouldn't even begin to be addressed for months after they were identified. And with certain companies, it might be 6 months before a bug would be addressed, and by that time, several more surrounding that particular incident might be also reported, and it would just be like a never-ending process to try and get the product working the way you wanted it. So let's look at what could be done to make this better. And in order to do that, I'm going to go through just um, a simple scenario. In the following screen, and I did really good to draw this by hand with a mouse. So if you look at that and you go, "Wow, this isn't very high tech graphics," it's the best I could do. Um, but an example of difficulties is you have children, they play. Um, Playgrounds at school or wherever, it doesn't matter. Unfortunately, when they're playing, accidents happen. And so you'll notice in our little graphic screen here that um, our little child has, in the process of playing hockey, at least I hope that's what it looks like, that he's managed to fall down and break an arm. That's quite the break, but it's the best I could do once again. So in the past, fixing something like this would require a trip to the doctor. Uh, it would require riding the car to the ER. You know, when we got there, there'd be a registration process with lots of forms. In fact, you'd have to wait a long time just to even get to the registration desk, and then you'd get shoved in a little curtained room, and after a bit of waiting, you'd get to see the doctor. Now, I'm not saying that the doctor was slow, but the process of getting to see the doctor took a long time. And I'm going to continue down on the then process, and we'll come back to the now process and what HL7 has done to make this faster. So back then, the patient would be sent to radiology. So toddle mom and dad with the kids, they go down and they'd have to check in at radiology, and that whole process would be repeated. Um, our little kid who's got a broken arm is suffering horribly while we fill out new forms, and then he gets put into a room and images are taken. That part hasn't changed a lot, except back then they used film, so there would be a long process to get the film developed and to make certain that the images that were taken were good, and that the doctor could actually see what was going on. And that's what would happen is the doctor would look at those images on the film, and he'd see, hey, it's a broken bone. He'd set the bone, he'd put the arm in a plaster cast, and send mom and dad on their way home with a prescription for pain. um, the patient goes home, parent goes to the pharmacy, and the kid wonders what the heck the term RX means. First time little kids, they don't know. Um, the next step here is about 6 weeks later, the cast comes off and the bill for things start to arrive in the mail. So that's the way it used to happen. It was a pretty complex process, but HL7 allows data to be transferred automatically. So now there's still the trip to the doctor. Sometimes that's facilitated by an ambulance, but most of the time I think that people throw the kid in the car, our kids in the car, and they go to the doctor. And registration is fast now because computers have helped us out. And just a few seconds with a last name and maybe a couple other questions. And if it's a return trip, you're registered. The doctor, or excuse me, the check-in process might ask a couple questions like, is there anything new, any new allergies or any medications that we need to know about? But for the most part, the registration process doesn't take an hour to get to be put in that little curtained room. It only takes a few minutes. Um, Once in the room, the doctor still comes in and visits, and kid's still sent to radiology. But once down in radiology, um, the order for what needs to be done in radiology usually precedes the patient getting there. Um, Once again, the computers and the transmission of the data and all of that stuff is just fast now. So the patient check-in once they get to radiology is fast. It's oh, what's your last name? Okay, you're here for an X-ray of the arm or whatever it happens to be. So the radiologists receive the order, they take the images, and they even get before they even get the images, they get to have a technologist actually review the images and make certain they look okay. So if they have to reshoot the images, it just takes a few minutes. It doesn't take 30 or 40 minutes for film to develop and dry and that type of deal. Now a patient gets a temporary splint and gets sent home while the parents make an appointment to see an orthopedist because need to know if it's really just a broken bone, if there's more involved, and exactly how to set that bone, and all that's done. All that communication, even with the orthopedist, can be done via HL7. Um, so all of that stuff happens, and the only thing that your child recognizes that they don't want to play hockey ever again until the cast comes off anyway. That's usually the way it works. But anyway, the orthopedist sees the break, determines whether surgery is needed or if it can just be a simple set. And if not, the break is set, fiberglass cast is used instead of that old heavy plaster stuff. And oh wait, 4 to 6 weeks later, the cast comes off and lots of bills start coming in the mail. So that part doesn't get changed because of HL7, but the accuracy of the bill is because of our computer system and HL7 and the software packages that uses HL7. All of that's a lot more accurate than it ever used to be. So this is just a review of in the now scenario. After the patient's checked in, the patient's information is placed into the medical facilities information system. If they haven't visited there before, then there's a little bit of typing involved to get registered and checked in. But once that information is into the hospital system, that information is put into their system, and then it's placed into HL7 messages, and those messages are sent to the various hospital systems that need the information. Now, this is a pretty important part of HL7 and the need for specific entities within the hospital walls to get information. Um, there should be no paperwork laying around with, personal health information, being exposed. When it's in the computer and the information is being shared only with the vendors that need it, it becomes a lot more secure. And that's just a total benefit that HL7 and computers and programs are behind this whole situation at this point in time, because I'm not saying people or entities don't get hacked. There's certainly has been lots of indications of that over the past few years that information from universities, hospitals, well, actually, you name it. That computers have been hacked and private information is available, but um, it's uh, it's not like it's file boxes that get put dumped in the dumpster now and that type of deal. So, and each vendor, the bottom bullet point is important there, that each vendor will only get the information that they need, and that's a very important process. It's not just up to the HL7 messages to determine what information another vendor needs, but the computer software that generates those HL7 messages will only put the information in those messages that's needed and only send those to the vendors that need it. So, for example, patient gets checked in. Doctor says I need to send this person to radiology for an X-ray of the arm. Um, that's ordered right there, and before the patient ever gets to radiology, the order has already been placed. The prescription is, if you will, has already been made for what's going to be done in radiology. And HL7 messages, or that information that's being sent from the front desk to radiology, how are they sent? Well, they're sent over the network. And what's a network? Well, a network can be a local area network. So, in other words, in your hospital, most of the time, the local area networks are now wireless networks. So it's like having a cell phone or radio or whatever. But they can also be wired networks. Where a cable runs between all of the connected parts and pieces. They Networks can be what are called wide area networks, even where multiple buildings are involved. And we talked about wireless networks, but the one important thing about HL7 messages being sent from, on a network is that the networks must be secure. And thankfully, we have very competent IT folks that make certain that networks are secure. Matter of fact, I know that in many cases, IT people will remove all permissions and then make folks like Novarad request the permissions they need in order to get messages sent and received, so that only the bare minimum information is allowed to go across the network, and it's really a great thing. So think of sending an HL7 message as being similar to making a telephone call. The message sender looks up a telephone number and an extension um, of the receiver on the receiver server. So, um, we're making a phone call. We're saying, "Hey, I need to dial 888-111-2222." And when I get there, I need to look for extension 12345, or however you want to do that. But in networking terms, that telephone number is an IP address. So behind the scenes, that's all part of networking lingo. That IP address um, is a series of numbers separated by periods, and the extension is a port on the network. So let's really be confusing, and I don't mean to be, but an IP address would be something like 127.0.0.1. That's a network. That's a place where information can go, and it's separate from another network that also might be on your hospital information systems being of like a 10.10.10.2. So those networks are separate and the information that goes across them are separate. But once you get the information gets to where it's going, it needs to be able to knock on the door or ring the extension and say, hey, I've got information for you. And that's what the port is all about. And the port is just usually a 4 or 5 digit number. And there's like over 60,000 ports that can be available for networking and software packages that use HL7. So the combination of an address and a port is known as a socket. It's not that's not going to be on a test or anything, but if you hear somebody referring to the term socket, it's just a term that means that we're combining the information of a connection of an IP address and a port. And oftentimes you'll hear something like, well, we can't communicate right now because the network's down or because the socket has been disconnected or something of that nature. So in the back of your mind, just keep in the back of your mind, I'm saying that IP address and port is all part of that, and all of that is part of your network. So HL7 isn't the network itself, it's data being sent over a network, and it relies on networking to be able to transmit its data. So it's not in this particular presentation, but HL7, that term means health level 7. And that is what that group of doctors that we talked about at the very first all got together to do, is to create a language and a software package called Health Level 7. And why Health Level 7? Why not Health Level 8? Why hasn't it grown over the years? And it's because that Level 7 is a layer in the networking arena where HL7 messages are transmitted. There isn't going to be a layer 8 in the networking package, if you will. It will always be layer 7 is where the HL7 messages are sent. HL7 messages rely on the network being available, and for things like your cabling and the network card in your computers and in your software packages and all of that to already be functioning and working when they get to go out their front door, so to speak, and move on down the road to transmit their data. So let's look at a simple HL7 message. At the top of this screen, you see two lines. You see one line that has the letters MSH at the beginning, and the second line has the letters PID at the beginning. And this is a very simple HL7 message. You won't see anything any more basic than this. But what you can tell by looking at this is that HL7 messages are text-based. In other words, you could, if you get an HL7 message, or somebody gives one to you in by whatever means, in an IM or in a email, secure email or whatever, you're able to look at that HL7 message with a text editor like Windows Notepad or Windows WordPad or whatever you want to use. You could even look at it if you want to, use Microsoft Word or some sort of bigger package. You can do that because these messages are just text characters. They in the sample message above, you can see that. You can see that we have two lines of information. And in those two lines, let's go back to our sample poor young man that got hurt with, or young woman, I don't know, I didn't even specify that. But anyway, the poor young person that broke their arm, let's say that his name was Walter Test. And if Walter Test was his name and we're looking at this HL7 message, you only see one spot with Walter Test in it, and it's backwards, it's Test Walter, and it's on that second line. So what's important about that is that data location is specified by the HL7 specification document, and that's done by the HL7 committee. The people that actually made HL7 decide where information is going to be presented and what the standard will be. That doesn't mean that folks might not alter the standard a little bit, but it does mean that there is a standard. And like in this case, Walter Test, his name is found in a specific spot in that HL7 message, and it doesn't matter what message you look at. If you're looking for a patient name, it will be in the same spot. And we'll talk about the spots in just a second. So this sample HL7 message to continue will tell another vendor when the message was sent, who sent the message, what to do with the message or with the data in the message. There's no guesswork involved. All that information is found in that very first line of information that you see. So I'll back up just a tiny bit to say that HL7 message construction. So in order to make an HL7 message, an HL7 message is made up of segments. A segment is, in this case, if you look at it, it's a line of text. It begins with a little three-letter word. There are always three letters, and they're called mnemonics. Let's see if I can spit that out. But they're called mnemonics. Sorry about that. And they just mean something. For example, that MSH means it's a message header. And after the message header, there's all kinds of information about the message. So continuing on within a segment, data can be found within fields. Fields are just the information that you see between those vertical lines in the message. Those vertical lines are called pipes. And pipes don't have to be used to separate data into fields, but the HL7 specification recommends it, and I've only ever come across one vendor that uses something different than pipes. So when you're looking at an HL7 message, you really know that it is because you see all those pipes on what you're looking at. So within those fields that are separated by pipes, those fields can be separated even further. They can be separated into what are called components. So if we look on the second line where we see Walter Test, his name is separated by a caret. The caret meaning the hat or the up arrow or the tick, or I've heard 100 different names for it, but the caret separates the components or the subfields, if you will, within a field. So we have Test being a last name separated from Walter being a first name with the caret. Those components can be further broken down into subcomponents. Subcomponents are um, are recognized by the use of an ampersand within those component fields. Now, subcomponents are pretty aggressive HL7 programming. They aren't used very commonly, not at least in what Novarad does. Novarad's radiology for the most part, and we can do everything with fields and components and subcomponents. But other vendors need to get way more detailed with their data, and putting subcomponents in with the ampersands is pretty important. The nice thing about looking at the message that you see above is that way back in the old days, all this information could be transferred in what was called a comma-separated values file. And what that means is that every field, instead of being separated with a pipe, would be separated with a comma. And the component fields would also be separated with a comma, and the subcomponent fields would also be separated with a comma. And so that message would start getting longer and longer and stretched out. And just by visually looking at the message, you would not be able to tell where, for example, the patient's first and last name were, and if that field was even stretched out further to have, for example, a phone number and an email address and whatever. else might be personal to that particular patient, you wouldn't know it because those commas just stretch everything out, and you have to count commas and comma separated value files. You still have to count with pipes in HL7 messages, but it's a little bit easier to count the pipes and recognize the data within it, whereas with comma separated files, it's not. So sorry, I kind of got sidetracked on that, but every HL7 message will have an MSH segment. So remember on the previous screen, I said every HL7 message has segments. Segments are defined with a three-letter mnemonic at the beginning of the segment, and then data is held within pipes within those segments. So the MSH segment is known as the message header, and it tells another vendor exactly what to do with the message that's being received. We'll talk about some of the specific pieces of the MSH segment, but for the most part, it tells another vendor who sent the message, the date and time the message was sent, what kind of message it is. In other words, what do I do with this information? And some other things that make the message unique. Um, it tells another vendor what version of HL7 is being used, and if the message a uh, is a test message or if it's a production message. So you see all that information in MSH segment, and that's kind of great because there's no guesswork involved when I receive an HL7 message in Novarad software. I can look at this MSH segment and tell exactly what needs to happen. So depending on the HL7 message type and event, we'll talk about message types and events, other segments will be included within the message. In this particular case, you see a PID segment following the MSH segment. Um, and that's kind of an important segment because it stands for patient identification. So it tells a lot of information about the patient. For example, we saw his first and last name there. It gives an MRN or a patient ID. It gives his birth date. It gives his address. It just tells whether he's male or female, if he's single or married, who his what his mother's maiden name is, and there can be a ton of stuff within that PID segment. Much of which you don't see on this screen because this is just a very simple message. So the HL7 message type, what the message is supposed to be doing, is found in that first line. And if you look over to the right, you'll see the letters ADT. So ADT means that whoever receives this message is supposed to do something with patient information. That ADT stands for admit, discharge, and transfer, and it's all patient-related information. So that another vendor will get this information and say, hey, I'm doing something with the patient. And so what to do with that information, with the patient is found in that next component that you see after the hat where you see ADT. And that's in this case, it's an A08, but we'll talk about that in just a second. What's important to note that a vendor might not need to support all HL7 message types. For example, Novarad only supports the following HL7 message types: ADTs, ORMs, ORUs, bars, DFTs, and MDMs. So went through that kind of fast. What they mean is you can see in that center column, and what they're used for you can see in the right-hand column. But for the most part, they mean almost what they sound like. An ORM is an order message, and it's used to provide an order for a procedure that's going to be done. Need an X-ray for the arm. An ORU is probably the least. I can tell what needs to happen with it the least, because it really stands for observation result unsolicited. Don't worry about that. But it's the message that provides a diagnostic report from a radiologist. And so you can see that Novarad can do a radiology type environment on 6 HL7 message types. To continue, I told you that there was an HL7 message event, and you see that right next to ADT, and it's highlighted. In this case, it's an A08. The event tells the receiving system what it should be doing with the HL7 message type. So in this particular situation, the message event is A08, and it means that the patient record should be changed. And it should be changed to reflect the data that's in the HL7 message that's being sent. So every HL7 message type will have a varying amount of events. For example, the ADT messages um, have over 60 different types of events. They tell another vendor what to do with the patient, whether the patient should be merged, whether patient data should be updated, whether it should be a new patient, whether it's not really a patient, but maybe it's a person or a physician, or and it just depends on what the software package is doing that's receiving the ADT message. So once again, the very bottom line says each HL7 message type will have a varying amount of events, and those events are determined by the HL7 specification. And you'll note that your HL7 engineers and whoever's helping you out with HL7 will know what those HL7 message types and events are, what they do, and um, it's a pretty complicated thing to understand, except when you get the HL7 specification and you look at it and it says, hey, if you've got an ADT A08, you're supposed to update patient information, it all of a sudden becomes a lot easier to understand what's going to happen. So um, this just reviews what I told you a few minutes ago, that in HL7, the ADT message type contains 60 events. And in later versions of HL7, it might have more. Please note that this says HL7 version 2.3. So there are HL7 versions from 2.2 through FIRE. So 2.2, 2.3, 2.4, 2.5, 2.5.1, 2.6, excuse me, 2.7. They skipped 2.6, 2.8, and into FIRE. And they all do something specific for what's needed. For example, Novarad can use HL7 version 2.3 because we're a radiology company, and version 2.3 isn't specific to radiology, but it doesn't have a lot of information that's not needed by radiology. So a later version might include something that pharmacy transmission might need, or that um, food services might need, or there's a lot of things that rely on data transmission within the walls of a hospital. So a different version of HL7 would be used, and more information or specific information to what's being communicated to and with, and that type of deal will determine the version of HL7. So HL7 version 2.3 doesn't mean you're using an old version of HL7. It just means you're using a version of HL7 that's specific to in this case, radiology. So Novarad only uses a small portion of all of the ADT events. So you remember that Novarad only used 6 HL7 message types. And now with ADTs, I told you that there are over 60 HL7 events that are associated with ADTs. Novarad only uses um, about 5 of those. We've added to the number of events that we can support since I did this last year, and I haven't updated the slide, but still the basic concept is that an ADT message is used to create or update patient information. And you can see there that it's create, register, pre-register, update patient information, merge patients. Novarad does not support deleting patients via ADT events, but there's a lot of stuff that you can do just with massaging patient information. Now, um, this slide tells a little bit about some limitations that you should understand. So in ADT messages, an A01 event tells an HL7 broker to create a patient record if one doesn't exist. An A08 event can be used to update a patient's record, but an A01 message can't update a patient. It's not what it's designed to do. If you receive an ADTA01 message and it's for a patient that already exists in the system, the ADTA01 message is done with its business. Nothing else will happen. If you need to update the patient information, the vendor needs to send an ADTA08 message, and if they do, then the patient record will be updated. But even notice that an A08 has some limitations. It can't merge a patient. It can change information, but it can't actually merge two patients together. So there's a different ADT message type for that. And as we take a look at this particular chart, it shows at least what the events that Novarad supports, what they do. So if you want to merge a patient's records, you'll notice that there's an ADT 818, and that's used for merging a patient's records. So sometimes information doesn't get transferred as expected. So you'll be looking at in Novaris, and you'll say, I don't see Walter in our system. What happened? I don't understand. So, in diagnosing a problem, I've got to reinforce the thought that we have some great trainers at Novarad, and they do a lot to try and help all of our customers understand how to look for information within our products. HL7 is part of the product called Novaris. It's even though you might be using a PAX only product, if you have HL7 involved, then Novaris has been installed and is running in the background because HL7 is part of that product. So in order to see if there's been a problem, you'll need to open the Novaris administration console. If you should have access to it, and if you don't, then that's time for a call to the HL7 team, or excuse me, to the technical services team at Novarad. But open the administration console, go to the event log. That's the very first tab in the event, or excuse me, the admin console, and just add certain filters to search for the date and time that the issue should have occurred. So, if we take a look at this sample event log, you'll see that at the bottom you have a whole bunch of results because this was an open-ended search. But if you wanted to find a message for Walter test, you could put in Walter in the filters for the search and set a date and time that, the last couple hours, couple days, whatever, and say I want to look for HL7 message and hit search, and it will come back and it will say, hey, I didn't get a message for Walter test, or somebody tried to send Walter test, but the information was way wrong, and we might need for the information within the message to be straightened out. So when you're trying to find information, don't be scared to come into the risk admin console and look at the event log and use some search filters or some search criteria in the search filters and see if you can find out what might have happened. And our technical support team stands ready to help you if you can tell them maybe even just a little bit about what's going on. Like, hey, I don't have Walter tests in our system. His information should have been sent from ECW 2 days ago or yesterday or even earlier this morning, but I don't see it. Can you help me find it? And they're pretty good about helping locate information if and being able to determine why a message might have failed. If you do find an error message, you can drill into that error message and you can see maybe a little bit more information. So notice that this error says I'm unable to process an incoming message from, and in this case it's a file name. Came from the failed to process folder because messages are retried after they fail, but it tells you, if you read down a little bit further, it tells you why. It says, hey, the segment PID has an element in position 8 that is invalid. The value of element 8 is not one that's defined in table 0001. So I know that table 0001 isn't going to be necessarily one of those things you've got memorized, but if you call technical support and you say, hey, here's the error message that we think goes with this, it looks like there might be some bad information in PID 8. Can you help me figure this out? And every little bit of information that you can give the tech support team helps. It will make the resolution to the problem happen much more quickly. So HL7 is really a language designed around communicating data in a more simple and structured fashion. It doesn't mean that a vendor might not want to follow that. For example, I've worked with other vendors who say, "Hey, I don't want to receive a referring physician. I don't want to receive it in PV18, which is where it's supposed to be, according to the HL7 specification. I want you to send me that information in OBR 16. Okay, sounds all Greek and everything. When you've been doing it for 17 years, it's not as Greek as it might sound, but that's my benefit for having done it for so long. Trust me, I was pretty lost at the beginning of all of it, but it doesn't matter. What matters is that Novarad's HL7 broker is able to be maneuvered or massaged or whatever you want to say so that it can send that data in a field that another vendor may want it to be presented in. If another vendor is sending that information in OBR 16 and they'll tell us, hey, referring physician, we're not sending that in PV18, we're sending it in OBR 16. Novarad's HL7 engineers can adjust their HL7 mapping so it can receive that information from that other field. So whereas their HL7 is a standard and it should be followed, it's not always followed. It's a little bit easier to manipulate the data that's coming in into an HL7 message and to read it than, for example, than to try to manipulate DICOM images. DICOM is a much more strict standard, but it's still HL7. You can still get the information that you need and that type of deal. So one last thing to tell you is that normally when I do HL7 training, I can take up to a week to train our Novarad's escalation engineers for most of the detail behind, some pretty complex HL7 stuff. And that week is 8-hour days. So when we're stopping here, this is very basic uh, review of what an HL7 message is, how they came to be, what they're good for, how they speed the process up, how things are, can be organized, and that it is a standard. That kind of stuff is what I was hoping to cover today. So I would like to thank you for your participation, and if you have any questions, I'd be happy to take the last few minutes of class and work with you on a question that you might have. Please note that I'm not really going to try to delve into a big deep case or anything that you might have with Novarad's technical support. But if you have questions about HL7, I'm happy to answer them.
We have Kimberly Hopman in the chat just saying thank you for all of the information.
Oh, I hope that it made sense. I really do. Thank you, Kimberly. Well, Erica, if they don't have any questions, I still welcome questions to come in and I'll answer them via email. I'm more than willing to share my knowledge set. So with that, I guess I'll turn the time back over to you.
Perfect. And thank you, everyone. Again, just like Bill said, go ahead and email us. I put the email in the chat, usergroupquestions@novarad.net. Feel free, if any questions come up in the future after this class, go ahead and email us there. We'll send them over to Bill and he will respond in the time that he has and get back to you. So again, everyone, thank you for being here for this year's user group. Everybody have a wonderful Thursday. Bye-bye.